Hi, this video is to show you how to solve the interval estimation problem for the difference in two population proportions. And I'm going to use the example we have in our slides, the tax preparation firm case. Tax preparation firm is a firm that prepares tax returns for their customers, and they want to verify if the two offices vary or how much they vary in their proportion of erroneous returns prepared at these offices. Okay, so we're going to compare two offices, and this is the data. Office number one, we have 250 tax returns, 35 with errors. Office number two, we have 250 and 27 of them with errors. So if I divide 35 by 250, I have the proportion of tax returns with errors. The same thing here, okay? So that's the situation. We want to build a confidence interval to estimate the difference of these two population proportions, because these are proportions, okay? So there's no mean, there are no means here, so that's the reason I can figure out that it's a proportion too. That's a okay. So I'm gonna be using the formula which I have the differences in proportions plus and minus a z-score multiplied by this standard error here. I'm gonna do that in Excel. So let me open the file tax preparation. Tax preparation is the name of the file. I have office 1, office 2, and we're gonna estimate the differences. So office number 1, sample size, I'm gonna use the formula count A to determine the sample size here. So it's 250, the other one is equal count A also, okay. Now the proportion of errors, so is equal count if. I'm gonna use a count if function, and I'm going to select the range without, don't include the label, so below the label, because yes represents those cases with problems, erroneous. I'm going to type quotation marks yes and close parentheses, and this is going to count in this column, in this range, all yes that we have 35. And then let me do this proportion here is equal 35 divided by 250, that's the proportion. And if I do that and copy here, I'm going to have 21. Let me check. Oh, there is more here. That's the reason it's good to check. I have 300 cases and 27 erroneous. So the data set is a little bit different than what we have here. Here it says 250 is really 300, okay? Because the data set has 300. The proportion is what we have in our slides. So that's the proportions, okay? Now I'm going to compute the standard error. So I'm going to compute this part of the formula under the square root. This is called the standard deviation. That comes from this formula here. Standard deviation is what I'm going to compute. So I'm going to start with the p multiplied by 1 minus p. This part here, p multiplied by 1 minus p, is equal to proportion multiplied by, open parentheses, 1 minus the proportion. Okay, and then I do this number here divided by the sample size, and then I have these terms here, okay. And then I'm gonna simply copy this and make sure that I'm using the correct information. Okay, so yeah, it's okay. So the sum, I did this, then I did this, now I'm gonna sum them. So the sum is equal to this number plus this number. I have everything under the square root. Now I take the square root of this number, and that's my standard deviation of the differences in the population proportion. Okay, that's the number that goes underneath here. All right, so now the confidence level. Let's say I want 90%. The coefficient is 0.9. The alpha is equal to 1 minus coefficient. I get the alpha divided by 2. I get this number 1 minus the alpha divided by 2, and my z is equal to norm dot s because it's a standardized value, and I select 0.95, 1.644. If I reduce the decimal places, 1.645, which is the same number we have here. So this is the z-score. I simply computed the z-score here. I have the standard error here. Now if I multiply them, I get my margin of error. So this number multiplied by this number is my margin of error. Now I have the point estimate for the difference. What is the point estimate for the difference? Is 0.914 minus 0.09. That's the estimate for the difference. The difference between the two is our estimate based on the sample. Now, how much is the upper level? Okay, this 0.05 is this 0.05 here, which comes from this difference. So if I get this difference and add the margin of error, I have 0.095. If I get this estimate and subtract the margin of error, I have 0.005. So that's the numbers for the lower and upper limit. So this is how you use Excel to get the interval estimate for the difference in two population proportions.